Okay, so hello everyone. Today I will be talking about addition and subtraction of logarithms. So I want to prove the formulas a little bit and not just state them. So the formula for the addition is basically that equals logarithm of a plus logarithm of b. And while this is legit, it's important to remember that it only happens for the same basis. So, for example, you cannot do it like that logarithm a plus ln of b equals logarithm of ab, because here you have e as the base and here you have 10. So that makes no sense. Okay, so from this we will start from the right hand side and move on to this. Alright, so first things first, we need to express these in a simpler, more visual way, because let's be honest, most of us don't really see the logarithm when we think of it, but when we see 10 to the power of something, then that's much easier. So that's what I'm gonna do. So let's say that logarithm a equals 10 to the power of x. No, wait, what I'm speaking. Equals x, and 10 to the power of x equals a. Similarly with logarithm of b, equals y, and 10 to the power of y equals b. Alright, so now that you have it, you can just write that logarithm a plus logarithm b equals x plus y, because that's what we get from the substitution here. To get to the logarithm of a times b, we need to consider another letter. So let's say z equals, no wait, I'm sorry, it's late. 10 to the power of z equals ab, right? So now you can see that you can get ab by actually multiplying these two. So that's what I'm gonna do. So 10z to the power z equals 10 to the power of x times 10 to the power of y, because that's our ab. From this we get that, because when you have 10 to the power of anything to the power of something, then you add up the powers. So it's 10 to the power of x plus y, and let's don't forget that our 10 to the power of z was equal to, it was a substitute for our expression for the left hand side. So now we just have to simplify it a little bit. So from this, and this, we actually get that z equals x plus y, while x was our logarithm of a, y was our logarithm of b, and z was our logarithm of ab. So now that we have it, we can just write here z, which is equal to logarithm ab. So yeah, what is it? I don't get it. So yeah, that would be all for the addition part. So that's this one. And now we're gonna do subtraction, which is pretty similar. I mean, it's just the same thing, but with minus and not plus. So let's get started on it. So again, logarithm of AB equals logarithm, oh my god, no. Logarithm of A divided by B this time equals logarithm of A minus logarithm of B. Okay, yeah, and that's what we want to prove. Then again, I prefer to start from the right hand side. So we're just gonna write it down real quick. And again, I want to express all these as 10 to the power of something. Like just, you know, just to visualize it a little bit. So here you have that z equals logarithm of a by b. Hence, 10 to the power of z equals a by b. From this, you get that x equals logarithm of a, and from that you get that 10 to the power of x equals a, and from this you get the same thing but for y and b. So y equals logarithm of b, and 10 to the power of y equals b. And yeah, that's all we need basically. So now that we have it, we can write this as x plus y. And now we have to figure out how to connect z to x and y. And we can see that we can just divide this by this, and we will get ab on one side and 10 to the power of something on another. So a divided by b equals 10 to the power of x divided by 10 to the power of y. And again, from the power rules, when we divide something to the power of something by the same base, the power of something, we just subtract the powers. So that will be 10 to the power of x minus y. And yeah, and now we can just compare it to 10 to the power of z. And again, from that we have the same bases. So we can just say that x minus y equals z. Yeah, and I didn't misclick here again, but that's alright. And yeah, that's the same as this. So that's just z, and z is our logarithm of a by b, which is our left hand side. And that's basically the end of our proof, if I can even call it a proof. It's just like I don't know, explanation, I hope. And yeah, we can actually write it as well here. Alright, so yeah, that would be it for this video. I hope it was helpful and that you guys enjoyed it. And yeah, let me know what you think about it. And yeah, thank you for watching. Bye bye!